Alright, here's where things get darn tricky. So, it would help if I had something to stand on. But I'm going to try and do this without moving a bunch of stuff here to get this in here. So you're going to open up the sheave here to the maximum, which is simulating the smaller diameter pulley. So I know that I got to move the lever towards the higher speed, which is going in this direction. So I've moved my lever all the way over that. Allows me to open the sheave all the way up so that I can push this belt all the way closest to as far into the center as I can. What that's going to do for me is that's going to give me more slack over here for when I'm fighting with putting this belt onto the pulley of the motor once the motor's installed. So that's the first tip that I could give anybody putting one of these in who hasn't done one. And then next thing I got to do is I'm going to lower this whole unit down in here, and I've got to get this cogged gear that drives this low range drive belt. I'm going to get that in, and the tricky part there is I've got to get this belt to want to ride up onto this as I'm lowering it in. So the way to do that is to actually rotate this a little bit while it's while I'm trying to do that. So that could be tricky, to say the least. And then the belt, this whole top isn't wide open. There's a hole here and there's a hole there. So there's an intermediate piece here. So this belt actually has to get fed through there. So I've got to kind of pull this over, get the belt back underneath there, then move it forward, then drop it in, and hopefully get that gear to, that low range belt to engage okay. There goes nothing. Start by putting it up on here on the front. Get the belt going in the direction I want it to go, back underneath here. Lower it down one more step. There we go. Belt's gonna go there. Oh! Alright. I've got to get myself some height here. It's too difficult to do it without being able to have a little more height. And of course I got to orient this. I know I've got the handle over all the way towards the highest speed setting, so I want the handle in this orientation here. And then there's a hole here that is not threaded, and it's right next to this threaded bolt hole for removing this thing. That goes onto one of these locating pins, and then of course there's one in the rear. So of course the challenge here is it's virtually impossible to see that other belt. It's hard as hell to see whether or not that's even engaging. Oh, I also think that if you've got this in low range, it's easier. I'll put that down in low range. And the problem is if you force this, you're going to damage that belt. I can get my finger in there far enough to feel that the belt is out of position and it's not going to go down. So rather than force it and damage the belt, I need to pull it out and reset. Oh yeah, belt was completely out of position. It's tricky. That feels better. When you rotate this gear and you can see that it's moving the sheave, that means the cogs are engaged. So now if I pull this belt clear, I can rotate that one full revolution and see if it really is on there. That seems pretty good. It's probably close enough that I could safely start to drop this down and not damage the belt. The big bearing in that top head there it's a light press fit or slip. It's a slip, close tolerance slip fit there into that head. So that's why that isn't dropping down right now. So unfortunately there's no way to put something on the bearing itself that's out of race and push it because, well, you can't even see it. So best I can do is give it some persuasion with the dead blow mallet. There we go. Alright, now that it moved down a little further, I'm going to recheck my intermediate drive belt. And again, that still feels good. I got this darn bolt on the wrong side. Stop that. Oh, you stinker. There we go. Alright, my alignment pins are lining up. My extraction bolts that I've got screwed in are actually what's keeping it from going down now, so I can remove these. Working. Good. Alright, I screwed down this top here, and actually there's only 6 screws that go in there. I got this one large screw. Can't remember if one of these holes was oversized or not. I'll double check. But anyways, I just checked it. Goes into high and low, gear, neutral, everything like it should. My alignment on this handle might be off, but I know last time I had that problem, all I did was take out the 4 screws in the top here and rotate the handle 90 degrees to correct that, any issue there. So I'm not going to worry about that. So now if I undo my quill lock, the spindle goes up where it should go. And again, it's still a little persnickety to get it in and out of low range, high range, whatever. This is high range right now, it's direct drive. Popping it down into neutral is easy. And popping it into low range is easy. The hardest part is getting it back from low range or neutral back up into high range. That's a little bit more finicky. And I think the trick there is actually to, when I'm turning the spindle, I'm turning everything. And I think if we lock the top sheave and then rotate the spindle, there we go. Back into direct drive. Not bad. Oh, that brake is sticking. Now it's free. I don't like that. I wonder if there's an oil point or something for that mechanism. Alright. Next step would be to put the motor on, but what I'm going to do is I'm going to try running both motors on my VFD out of the machine unloaded, and just give a real good listen to the bearings on each motor, and the quieter of the 2 motors wins. So this thing's wired for 440 on the Donor Mills motor, so I've got to change that to 220 volt, and then something's rubbing against the fan shroud, so I'm just going to check that out. Alright, so to rewire this for 220 volt operation, you got to take this switch box off the side here and get to the wire pairs that come out of the motor, and they're actually labeled, and it could be a little hard to see, but for instance this is T7 and T4, so 7 and 4 are together, and on the side on the wiring diagram it actually tells you exactly how this is supposed to happen. So, for instance, over here for 460 volt operation, it shows that sure enough 4 and 7 is supposed to be tied together, 5 and 6 and 9. But what we want is we want 4, 5, and 6 all tied to each other and going nowhere. So I'm going to use one of these wire caps to join 4, 5, and 6 together and cap it off.
So that's 7, and that's 4. So 7 is going to be one of the inputs. Oops. One of 3 input wires for the 3 phases. So I'll just cap that off to keep it from getting mixed up with the other ones. And that's 8. That's also going to be on input. I guess I need to cap this off right now. And that's 5. So these two, 4 and 5.
I got to twist them the other way so when I put the cap on, that helps tighten them. So I was looking for 4, 5, and 6. That's 1. Alright, so continue to find that 4, 5, and 6. Alright, so there's 4, 5, and 6 that are tied to each other and nothing else. So that goes out of the way. Now I've got 2, 4, 6 wires left, and they're going to be in pairs tied to the input wires, which come from the switch. So that's why I got 3 wires here. So each one of these is going to go to a pair of those. Doesn't matter which ones really, because you can switch any two and all that happens is it reverses the direction of the motor. But since you get a forward reverse switch, I don't really care about that right now. But we do have to make sure that the correct pairs are made, which is 1 and 7, 2 and 8, 3 and 9. Oh man, there's a lot of dirt in there. Wow. I can't believe how much dirt was in this thing. Wait, it still is actually. The whole top of the motor here behind this fan is also all cruddy. But the only way I would be able to clean that up really well is to take the fan off, and I could tell just by looking at it that that's probably been on there a long time and not going anywhere, anyplace fast. So looking at it here, this blade is clearly bent right there. That blade right there, you can see going around that they were all pretty much pretty uniform, pretty good, and then all of a sudden that one comes along and it's like whoop, yep. So I'll bend that one back. So I got an interesting little noise coming out of this motor on this this end with the fan. That's not anything rubbing any longer. That's more than likely a bearing noise up in the top. Alright, so we're going to start with testing the motor that I've been using on the mill, that came with the mill, since it's already hooked up. And I don't know if I've ever run this motor with no load on it. I don't remember. Yeah, I think I did. But anyways. So it's at 60 Hertz now, so I'm going to run this down to like 5, because if I started at 60, that it should ramp up slowly, but just in case, I don't want the torque of the motor to send that thing wobbling off of there and falling. So there we go, you can see it think you might be able to see it spinning. So there's some interesting little resonance there. It's like at certain frequencies you can get it to start to resonate and make this really loud singing noise. I mean, I don't think that's a bearing. That's full speed there. Seems pretty good. Wow, that is loud. That is a weird noise. Alright. Gotta get the other motor and hook it up. Alright, so I didn't make that motor spotless, but I cleaned a ton of dirt out of it. And I also banged on that cover and got some dents out of it and everything, so that the blade, which is also kind of bent up a little bit, is not hitting the housing anymore. And that's going to sit there on the floor. I'm not lifting it up on top of this mill just for a side-by-side comparison. It's too heavy. I got a feeling I'm going to stick with my motor, but just for the heck of it, let's run this one. Okay. Oh, I've got the switch on that motor off. Oh, maybe not. Thought I had it off. Oh, there you go. Definitely noisier. Alright guys, so I'm now satisfied that I'm making the right choice by keeping my original motor. So I'm going to now install the motor, which is a little bit tricky. It's not too horrible, but I found that the easiest way for that is for me to just actually scale this thing like Mount Kilimanjaro. Alright guys, I got the my motor, well they're both my motors, but you know what I mean. The motor up here is now wired back to the VFD. And I put the gear, low high range assembly here in neutral. just because I want to make sure everything's spinning okay and that there aren't any bad noises or anything before I think about firing this thing up at a higher speed. I still got the head loose, so that I can float the head. Which floating the head is just the process of running the machine with that loose a little bit, so that it kind of self-aligns itself, and then tightening those down. Good so far, so let's shut this down and we'll get the range engaged. What do I want, low or high? Let's do low. Low's the one that's a little harder to get in. So again, get low range in. I think it's easier to just put the brake on and rotate the spindle while attempting to get this to go in. And doesn't want to. Why would it, if they're going through all that trouble? High works. It sounds a lot different than it used to. Sounds awful. Such an idiot, I had the brake on. Stupid brake sticking. Well, I mean, part of it was me had the brake on, but duh. above 2400 RPMs, it starts to act weird. I don't know if that belt's slipping excessively or what's going on there. Unless there's a way to tension that belt. Alright, kind of move the motor back. The holes are a little bit large, so I got a little bit of play. Alright, so I moved that motor back a little bit. That should put a little more tension on the belt, although it's kind of, the whole idea of tension is kind of a weird thing with one of these CVTs. We'll know what's going on there. Now, make sure that brake is off. Definitely have to address that brake issue. It's going to drive me nuts. This is high range. Like there's a lot of vibration in the top end. Up here. Worried about all that vibration resulting in poor finish. Vibration went away when I tightened up the head. It's kind of funny to me that for all the complaining I was doing about the way these bearings sounded when I put it all back together, I hear like barely any noise coming out of this whole quill spindle assembly. All of my noise is up here in the in the top. Can't quite tell what's going on here. This pulley seems like it's almost like it's too high, or this one's too low. It's actually, the pulleys are kind of like staggered like that, so I can actually see the belts going downhill. But I don't recall there being any way to change that. Hear this very discernible little chuk noise. Actually, I think that little noise is actually the that pulley down there with the low range drive belt going to it. Well, at least here's some good news. I put that R8 collet in with that precision ground pin in there, and got an indicator set up on it, and it's looking good. It's wavering at 1,000th, and that could easily be something with that pin or the collet. I tried indicating on this area of the spindle on the outside here, and the problem with that is that it's kind of rough from over the years, probably some oopsies hitting the side there, and I tried using some sandpaper to clean it up, but there's some actually pretty rough areas there. But I'm satisfied with that. Yeah, this camera doesn't really do a good job of focusing on tight shots. I just increased the speed a little bit, and it doesn't change. It's still just fluctuating between 0 and -1,000. Well, I'm still not convinced there isn't something still amiss here with the old Wells index. I'm only out 1,000th here, but when I put my finger on this while it's running, I can feel the vibration, and it seems to coincide with the noise that I'm hearing in the top end here. So I'm still wondering if there's something rotten in Denmark up here that's creating a vibration that's coming down the spindle and causing a problem here. The other thing, before I forget, I wanted to tighten down the locking screw, install and tighten the locking screw, that little tiny Allen set screw that keeps the spindle nut locked. And it occurred to me, I actually don't remember whether or not I finished tightening this, because I remembered I was going to wait until I put it in the machine so that I could tighten it. So I think I want to probably do that now. Wow, guys, I just put this wrench on here to tighten this, and found that in fact I was able to turn this just by pulling on it probably about 20 degrees. So it seems like this retaining nut had not been tightened yet since I put the quill in. So now that's tight. So let's tighten down the locking nut. Keep saying locking nut. It's a little tiny set screw. It's not really a nut. Alright, that should do it. Guess I should give it a whirl, see if it sounds any different. I wonder if I should put the indicator on it and indicate it again. vibration's still there. So the other thing I noticed was this shaft right here, which is kind of like an extension shaft that's bolted onto the end of the motor shaft. This almost looks like it's running out of true to me. So if I'm wondering if that's doing that, is that causing that pulley to run out of true, which would translate to definitely added vibration through the belt that could be transferred to the other sheave pulley and right down the line. So I don't know, maybe I should reinvestigate this other motor that I've got here, the spare motor, see whether or not that one runs out of true. And if it doesn't, maybe I should seriously consider swapping these motors out, even though this other motor did have a little bit extra noise in it. Alright, well, I'm going to quit for tonight.